The quicksort algorithm is a very efficient algorithm if you want to sort an unsorted quantity of elements. There are functions called quicksort which use this algorithm. Such a function receives an unsorted list. Let's say this is our unsorted list. I'll write a 1 in here because the quicksort algorithm is being used for the first time in here. And from this list, which we want to sort, one element is going to be remembered. This could be any element from the list. In this case, I'm going to pick Lisa as our pivot element. And now we are going to orientate ourselves by Lisa's size, and that's why I'm drawing a comparison line in here. And by using this line, we can tell very quickly which of the other persons is smaller or taller than Lisa. Now we take a green pointer, and this pointer is starting from the left and is going rightwards to visit every person once to find the ones who are taller than Lisa. And I have another pointer here, a red one. He is starting from the right and goes leftwards to search for persons who are smaller than Lisa. And the point where the two pointers meet is the point where the first search comes to an end. And now we begin. The green pointer takes a look at the first person. Is Peter taller than our reference element Lisa? No, so the pointer can go ahead. But first, we are going to move the red pointer by one step. Is Lisa smaller than Lisa? No, they are equal. So we continue with the green pointer. Is Tom taller than Lisa? No. So we continue with the red pointer. The red pointer goes ahead and reaches Fred. Is Fred smaller than our pivot element? No. So we continue with the green pointer again. He's arriving at Theo. Is Theo taller than our reference element? And yes, he is, so the green pointer is staying with Theo. And the red pointer arrives at Hans. He checks if Hans is smaller than Lisa. No. The green pointer has identified Theo in here, so he doesn't move. And we move on with the red pointer and check if Anna is smaller than our pivot element Lisa. No, so we go ahead. The green pointer is still not able to move because Theo is taller than Lisa. So we go on with the red pointer. He goes one step forward to Theo, and now both pointers point at the same element, so we stop moving the pointers. Instead, we check if the element at which they point is bigger than the pivot element. That's not the case, so these two elements will be swapped. We have run both pointers along here to check if the red pointer, which came from the right, can find an element that is smaller than Lisa. And we have checked if the green pointer, which came from the left, can find an element which is bigger than Lisa. That means we have ensured that left from the point where the pointers met, there are only elements who are smaller than Lisa, and right from this point, there are only elements taller than Lisa. By swapping Lisa and Theo, we divided the whole group into two groups. We have a quantity on the left and one on the right. Now we can go ahead with sorting the left one, as well as the right one. And we can do this independently from the respective other quantity and also independently from Lisa. And that's what we are going to do. Now we are recalling the quicksort function a second time for the left quantity. And after that, we are going to apply the quicksort function to the right quantity. This will be the third recall. This means we recall the quicksort algorithm again, this time for Peter and Tom. First, we pick a pivot element, in this case Tom. And the green pointer again starts at the left and searches for an element which is bigger than Tom. And the red pointer starts at the right and searches for an element which is smaller than Tom. So in here we are going to draw a comparison line again. And then we can start with the green pointer. Is Peter taller than Tom? Yes, this is the case, so the green pointer stays with Peter. Then the red pointer starts. Is Tom smaller than Tom? No, so he can move on. The green pointer doesn't move anymore. And the red pointer has moved on to Peter. And now both pointers point at the same element again, which is Peter. And now we ask again, is Peter taller than our pivot element Tom? Yes, he is. So these two elements are going to be swapped. And now we take a look at the surroundings of these two pointers. And on the left of the two pointers, there is no list anymore, which means we don't have to apply quicksort any further. But on the right of the two pointers, we have a list which contains only one element. But of course, a list which contains only one element doesn't need a quicksort as well. And we can see that the left area of the list is already sorted. And now we have finished the second turn of the quicksort function. So we start turn 3. We use the quicksort function again for these 4 elements. Again, we pick a pivot element, and this time we pick Theo, who is at the far right. And we bring the green pointer to the left at its starting position. It checks which person is taller than the pivot element. And the red pointer starts from the right again. It looks for elements smaller than the pivot element. And then we restart. The green pointer moves to Anna. Anna is not taller than Theo, so the pointer moves ahead. The red pointer moves to Theo. Theo is not smaller than Theo, so it moves on. The green pointer arrives at Hans. Hans is not taller than Theo, so it moves on. The red pointer arrives at Fred. Fred is not smaller than Theo, so it moves on as well. The green pointer moves onto Fred and meets the red pointer. And because of that, we ask, is Fred taller than our pivot element? No, he is not. So in this case, nobody will be swapped. And now we will check again what is on the right from Fred and what is on the left. To the right of Fred, there's only one person left. And for one person, we don't have to use the quicksort algorithm. To the left of Fred, there are two persons, Anna and Hans. We can use the quicksort there because there's more than one person in the list. So Anna and Hans will be our fourth list. Now we recall the quicksort function. So we restart. To the far right, we have Hans. He's our pivot element. The green pointer comes from the left. The red one comes from the right. The green pointer starts with Anna. Our pivot element is Hans. So green asks, is Anna taller than Hans? Yes, she is. So the green pointer stays with Anna. The red pointer moves to Hans and compares Hans to himself. And of course, he is not smaller than himself. So the red pointer can move on. The green pointer still stays with Anna. The red pointer moves on to Anna and meets the green pointer. So we check if the person at which both pointers met is taller than Hans. And that's the case here. So these two will be swapped. And if we look at the fourth list now, we see that there are no more elements to the left of Hans, and right of him there's only one person. And now we have finished every list and we haven't created another one. So the sorting is complete. And we can see that we have successfully sorted the elements according to their size. The quicksort algorithm divides his quantity into sections. So he works a bit similar to the binary search. But we have to visit every element with our pointers. So in here we have a complexity class of n times the binary logarithm of n.